Hello, everybody. Welcome back to another episode of the Flocode Engineering Insights podcast. Today, I have my friend Connor Ferster on the show. Connor is the king of structural Python, and he's going to talk about a whole variety of things related to structural Python. Connor, welcome aboard.
It's a pleasure to be here, James. Long-time listener.
A long time. Coincidentally, you live only a few blocks away from me.
It's true.
And,
It's true.
And we have both young kids, and I contacted Connor. I don't know, what was it, last year sometime?
Yeah. We went out for lunch.
Yeah, we went out for lunch last
Really appreciate
year and kind of figured out that we both had similar interests in the same field, although we both work on very different types of projects. So I guess for anybody out there that's not familiar with your background and what you've done to date, can you give them a high level overview of the Connor Ferster campaign?
The campaign. My name's Connor Ferster. I went back to school later in life to study structural engineering.
Sorry. I always forget this. The first question is, what is your life philosophy I can't believe I always forget this. What is your life philosophy in a nutshell?
I think the reason you always forget it is because it's such a heavy later conversation question. Yeah, and I knew you were going to ask this, so I spent a bit of time thinking about it. And here's what I'm going to say: is that I'll give you a quote. And when I first heard this quote, it must have been like 14 years ago or so. When I first heard this quote, it didn't really resonate with me. But then I've been thinking about it more and more and more, and then I realized that it's always resonated with me. And it's a line from the American poet Allen Ginsberg, and he goes, "Well, while I'm here, I'll do the work. And what is the work? To ease the pain of living. Everything else, drunken dumb show." And so what I mean by that is how it connects with me is that I realized that ever since I was a kid, like all the things that I imagined doing sort of in the world and for the world is sort of helping people enjoy doing what they're doing more, enjoy the living, enjoy being here, enjoy experiencing things. And so that's also ultimately why I got into structural engineering as well. Combine that with my own sort of interest in the structure stuff, right? But ultimately, I wanted to do it to help people and to sort of do the things that they couldn't do and be the expert and be the person that they could go to for technical help when they're in a jam. And so when it comes to the stuff that I do now with structural Python, having been in structural engineering practice now for 5 years, is that I realized that man, the structural engineering gig is a freaking tough gig. We can talk about that if we want, but there's a lot of pain points here, right, for a lot of engineers, and talking about how we work, the billing, the clients, time pressure, all this sort of stuff, right? And it seems that there's no real answer for it, right? And unfortunately, we have a lot of attrition in our industry. There's a lot of engineers that drop out of the industry, especially now. I'm finding that there's a lot of engineers dropping out to join the tech world because for various reasons. But the thing that I'm doing with structural Python is I want to make the lives of engineers just better. I want the experience of engineering to be what I imagined it to be, which is you come to work, you do this brilliant creative stuff, and you're hyper productive. You use your computer to throw off a whole bunch of automations, and you can check things, and you have a total view of everything that's happening. You give intelligent answers to your clients and suggestions. And then you go home at the end of the day knowing you did a good job and not worrying about stuff. And so that's the dream, but I don't think very many people experience that.
It sounds, what you've described is kind of like the 80s movie montage of perfect structural engineering.
That's how I grew up, I guess. So,
that's how I like to try and convince myself is how things are. But like so often it's like just a mundane problem that I'm getting so frustrated about. Okay, well, look, that is a very cool quote, and a pretty inspiring aspirations too. So now that you've shared that, let's get back to the Connor
Oh, sure,
Ferster
sure.
story. Thanks for
Yeah,
that.
you bet, man. So I went back to engineering school later in life. Um, I won't get too much into it, but I was a headhunter. I became a headhunter, a recruiter for engineers, actually, not structural engineers at the time. Just it was electrical engineers. And after doing that for 3 years, thinking that was sort of where I was meant to be, I just sort of realized that that wasn't, and I wanted to be the person receiving the phone call from the recruiter and the headhunter instead of being the person calling them. And so I gave a bunch of, I was giving advice to young people at the time that to go to technical college and to join the engineering technology program. So I decided to take my own advice and I went back to SAIT, which is Southern Alberta Institute of Technology, and I enrolled in the civil engineering technology program. And in my first month there, I was like, yes, felt like everything in my life sort of was leading me up to this point, and everything just clicked. I found that there was an opportunity to continue my education going to university. And so I was able to get into a transfer program. I completed my engineering degree in 2019 at University of British Columbia. And I've been working until very recently there at RJC Engineers in Canada, a very large, relatively old structural engineering firm, and had a really positive experience there. And then I just left RJC Engineers um, 1 week ago, not even a week ago, not even a week ago, to start working on my company, Structural Python, full time, which had been operating since the beginning of 2023 with full knowledge of my employer.
Very cool. Very cool. And so currently Structural Python as it stands, what is it and who's it for?
Structural Python is a training company for teaching structural engineers how to program in Python so that they can develop their own tools in a way that allows them to actually get faster. So we have this sort of engineering toolkit that we develop through our careers, right? And I don't know about you, James, but I was never sort of told to do it or taught how to do it. You just kind of start cobbling stuff together as you complete jobs, thinking like, oh, I might need that in the future. But then you end up after so many years with a bunch of the stuff, whether it's binders on your desk, spreadsheets, details you've drawn, calculations you've done in the past, books you've bought, articles you've read, you've circled notes in, copies of the building code where you've got notes, highlighted there. None of that stuff talks together, right? And so we have this engineering toolkit with a bunch of stuff that we have to sort of manually sort of sift through and copy paste, change, modify for jobs. And the whole process of keeping track of all that is like a huge workload in itself. And so Structural Python started off with the course that I created called Python for Structural Engineers. That was in 2022. And at that time, I had proposed to the Structural Engineering Association of British Columbia to develop a new course for structural engineers. Just as a side note here, if people listening are unfamiliar with the Structural Engineering Association of British Columbia, SEABC, no matter where you're from in the world, I highly recommend you check that out. The SEABC has a certificate program, a course program designed for structural engineers who are practicing. And the courses they offer are to fill in the gaps and to teach you professional skills that you don't get in school and that sometimes you don't get on the job. And so the courses that they offer it's a huge catalog, and there's semesters. I think there's 3 semesters a year, and they change the courses every semester, and it's some of the best stuff. There's engineers from all over the world that take it. It's not necessarily code specific to Canada, and even when it doesn't. Every building code is all coming from first principles, so it's not like it's going to be vastly different for you.
Mm-hmm.
But I highly recommend SABC. It's such a fantastic organization. And so that's the end of that side note. But the SABC course, I developed this course, Python for Structural Engineers, course E29 in the certificate program, and I ran it, and it had the second highest, or like like almost like it was like neck and neck with the highest enrollment they've ever had for a course. And that told me that there was a big demand. People enjoyed the course. There's a lot of mistakes that I made in that one, but then I repeated the course, and it was March 2023, but this time I was doing it privately through my own company on structuralpython.com. And so I had a live cohort of engineers, of like 26 engineers from around the world, Europe region, North America region, and Australia.
Mm-hmm.
And then I ran it after that one. I made some changes and made some modifications, got some good feedback. And then I ran it again and the end of 2023. And I had 41 engineers then. And then I learned a whole bunch there, made some changes, modified it, and then ran it again in 2024 in January. And then I realized that a lot of the things that the engineers were saying was that live courses were great. They kind of pushed them, but they needed something pre-recorded that they could access on their own. So I launched the pre-recorded course called Python for Structural Engineers, asynchronous lesson, and that was in May. So that's everything up to date in terms of what I've done. And now what I realized though is that Python for Structural Engineers is only in as good as you know what to do with it. And so I've been developing this sort of framework, this methodology, this idea of how to develop an engineering toolkit in a way that actually lets you get faster and faster and faster, as opposed to instead of having these sort of one-off tools. It's a way of developing an engineering toolkit that sort of compounds. So like the more you build, the more it helps it helps you, right? And so you end up building a lot of interchangeable pieces that can all connect together, as opposed to having just the stuff that we have and trying to figure out how to make it all work.
Mm-hmm. This is it's such a fascinating topic because our profession is so broad, and it includes people that work all day, every day on prefab hollow core slabs versus somebody who does, such a wide variety of things all of the time. So you've got the full spectrum of people that are doing repetitive stuff that seems conceptually quite easy to repeat and to programmatically create a toolkit that could address it. But then you also have people that are kind of doing, a wide variety of things where it's like, I don't even know where to start of how you would create a toolbox for something like that, because almost every project is its own new thing. So when you say engineering toolkit, what kind of comes to mind?
Yeah, good question. The engineering toolkit that I started teaching in PFSE, Python for Structural Engineers, is sort of looking at what are the things that like every engineer is going to need to do. You may do it at a greater or lesser frequency, but one of those things is everybody does linear elastic beam analysis, flexural analysis, right? You're going to need to run it, whether you're designing retaining walls or whether you're designing concrete beams. You're running a flexural analysis. So you got to feel for what your shears and your moments are, what your reactions are, right? Mm-hmm. So there's a part of the toolkit that's focused on that, and then the other part of that is columns. And so you are doing some sort of axial design. So what are the ways you can design a toolkit for that? Now, I'm saying it, and I'm sure there's a lot of people thinking like, oh, well, yeah, beam design, don't worry, I got that. I got my SAP 2000. I've got my Sky Sieve. I've got my whatever to so that I can plunk numbers in. Column design, that's all right. I've got my SP column. I've got my again SAP 2000 design. I've got my little spreadsheet to do that. And yeah, that's great. I'm not trying to take away from those things. What I'm saying is that those tools though weren't designed to sort of work as part of a larger whole. And so if you were to design a process for yourself that could do those things, but then was built in a way that could connect with more and more and more things, then you've got something that you can sort of start building from. And now the exciting part here is that you're right. Like not everybody likes the same things the same way, right? If you're a wood engineer, the demands you would have on your beam analysis tool will be different than if you were a concrete designer, right?
Sure.
So the things that you can do when you build it yourself, when you build your own thing, you can customize it to the way you want to work. And
Yeah.
so, and that's also what I've come to start teaching in the course. And so the those are sort of like the core tools. Now, also on top of that, right? There's capacity design, right? And you're determining capacity of things, and that those things become more specific to practices, to where you are in the world, to what building codes you use. And so when I teach things, I typically focus on the demand side of the equation. So if we look at engineering, there's demand and capacity. And then I typically start teaching on the demand side because that's the more universal part. The capacity thing gets more detailed, but I teach people how to start building tools on the capacity side in a way that becomes that really flexible, interchangeable, interconnectable system.
Yeah, and the capacity side has the added complexity of the differences in various regional codes and whatever.
Oh yeah, and on top of that, it also has the complexity of interpretation. Right. Just because
Yeah,
it's written in the code doesn't mean that everyone's mathematical interpretation is going to be the same. And so when it comes to building stuff for capacity, I really feel that the the, those things should be developed by the engineer practicing because that's their own interpretation, their own way of applying the code. Now, there's a lot of things that you might be thinking like, yeah, but uh, a steel beam moment resistance is the steel beam moment resistance. Not a whole lot of interpretation there, and I agree with you, right? But there's things that once we get more and more and more down the chain, things become less clear. There's some things that are
hmm
very clear and very straightforward, but then there's also things that are sort of less clear. And I think that also that becomes clear when you look at commercial software, right? And so any commercial software that does maybe say concrete beam design. I know there's a couple ones come to the top of mind, but I'm not going to talk about them specifically. I don't want to call anything out, but
you're not the first person that has refused to call out any specific software on this podcast, and I feel like it's big software are silencing
yeah,
flow code
yeah.
flow code
Well,
podcast
and
guests.
I wonder about that, right? And I mean, I guess part of that is that the longevity, right? So if I called out, say, I'll say S line or from, and I talked about blah 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 things that they don't do, then they change the software and then they come back, hey, I did it. Well, at the time you didn't, and it becomes all this sort of stuff, right? So,
Yeah,
there commercial software, there are deficiencies and they have to
sure.
do with code interpretation, what they do when they don't check, right? And unless you go through a rigorous process of checking their commercial tools, which every engineer should be doing, then you don't know what those are and you have bad assumptions. And so whether it comes to building your own toolkit or building open source tools or distributing tools, then
Yeah,
that those interpretations, what you have to do and what you don't have to do, when you have to do it, when you don't have to do it, those are things that I think become a lot hairier. And so I
yeah,
really feel that for people to build tools for that and put them out into the open source community, I think is a really hairy proposition. I say, develop, find ways of developing it for yourself, and then build those capacity design tools that work for you in the way that you work.
yeah, yeah. I couldn't agree more. And there's a lot of stuff that I have built that I'd love to share it, but first of all, some of it's commercially sensitive,
Hmm.
and then the other aspect is like, man, I don't know if I want to release this tool, which works great for me in this very specific use case, but I haven't had the time or the luxury to test it in a whole variety of different types of scenarios. And I don't want somebody in New Zealand screwing themselves over because they applied this function in a way that it was never intended.
Yeah, I find that a lot of times, we as engineers, we sort of have this, we imagine the other engineer, right? I don't
Yeah,
want I will know to check this thing, right? But the other
yeah,
engineer,
yeah, yeah,
they are going to screw something up. But and of course, it's not on you; it's on them
yeah,
because
yeah.
we don't. Nobody warrants an engineering tool saying, "Ah, yes, it is correct."
You know
Right?
that that touches on a very interesting tangent, and that is the prevalence of AI now in everybody using AI tools to develop code and clean up their code. And I still think that we're so far away from like really using AI as a licensed engineer because of the whole liability aspect. And we're a profession that's still protected by stamps because we're assuming liability for our designs. So I think there's a long way to go before we see any big companies say, "Oh yeah, we're gonna authorize this building design because we've trained it on enough drawings or models or previous projects or whatever." So it's food for thought for using AI tools. Very handy, but it's not a silver bullet.
Well, I've got lots of thoughts on AI, but I'll keep it to a couple here, just on the things you touched on, which is that, I mean, the thing with an AI response, these large, sorry, I'm not going to say AI. Let's just be more specific. A large language model response is probabilistic, right? And so with structural engineering, though, we operate in the world of determinism. The calculation always gives the same answer with the same inputs. Now, large language models do not work that way. And anyone who's tried to sort of use an image generator, that's not a large language model. It's a little bit different, of course, but the same idea, generative AI. Anyone who's tried to use an image generator and get like the same image twice, it's like, oh, I want that image, but just tweak this one thing. And it's like, oh, different image. And so they don't operate in the world of determinism. And so my friend Jesse, we were talking about, he was looking at building a tool that was going to kind of like automatically sort of read some drawings and identify walls and columns and things. And he was saying the thing is that if it gets one wrong, they're all wrong.
Yeah.
And that makes it really hard, I think, to use generative AI, large language models, and other related technologies in structural engineering. I do think that there's a place for machine learning, especially when it comes to sort of what's the word, asset assessment, bridge assessment, that sort of thing, structural assessments, right?
Mm-hmm.
Because that's a classification problem, and machine learning models are really good at classification problems. As a design engineer, you probably don't do classification problems during your day. I'm asking you.
I do a little bit. We have some good applications here for machine learning, especially on dam condition assessments and stuff
Right.
like
Yes.
crack
Assessments.
propagation,
Yeah.
conditions, all that kind of stuff.
Absolutely. It's evaluating existing infrastructure and its current state.
Exactly. Yeah.
Yeah, absolutely. Those are exactly. I think they're really great applications for it. But I mean, the last thing I'm going to say on AI is that, as a general sort of air quotes AI catch-all term, is that imagine that there was a generative AI that was so good, it was just like being another engineer. Okay, let's just say that exists. And so, for all intents and purposes, we could sub that out with literally another engineer, like a person.
Mm-hmm.
Now, I'm going to ask you this, James, and I don't mean to put you on the spot here, but when you were in engineering school, did you ever pay somebody to do your homework for you?
No.
Yeah,
And
and why would you not do that?
well, first of all, if I actually did want to pay somebody to do my homework, I'd have to understand what I want them to do and to give them like clear guidance of like this is exactly what I want you to do for the homework. And it's the same problem with AI where it's like you have to clearly define the problem and almost understand what the solution needs to be for it to be of any use. But if you
Right.
just blindly tell somebody, "Hey, do my homework," and then they just do some bullshit, you're like, "I don't know if this is correct."
Well, let's say they did some. Let's assume they're doing it correctly, right? Let's assume they're doing it
Mm.
correctly. You give them your homework, your foundation design homework, and you say,
There
"Hey,
is there is companies that do that, right?
let's say you give them somebody your foundation design homework in university, and they do 3 or 4 assignments for you, and now you're like, hey, great, got grades, 100%, awesome, but now you didn't learn anything.
He's a fraud.
Well, you don't know any. The purpose of homework is so you practice doing the things that you're learning about, right? And it's when you actually do it yourself, you go through the struggle. That's when you learn,
Absolutely.
right? And so to just as we were talked about the other engineer, right? Like we don't we don't give our outsource our work as engineers to just anybody. Even when they are licensed engineers, we still don't trust it, right? We
It's
You
true.
check it, you validate it, and you go through that process, and that's what it should be done. And so the idea, and then when you send that work out, you no longer gain that, like as a firm, let's say you send out all your steel design work, your detailing work, you don't get that competency in your firm anymore. You're outsourcing it. So
True.
whether you're outsourcing it to another engineer or whether you're outsourcing it to AI, you lose that ability to develop that competency. And so as an engineer, I think it's just a matter of like, do you want to be competent in XYZ or do you not want to be competent in XYZ? And generally speaking, I think in engineering or any technical field, programming or otherwise, it's just a lot more fun to be competent.
Yeah. More difficult.
Yeah, it's more difficult, but damn, it's fun.
Yeah. Yeah. And yeah, no, you raise a good point. And I find personally the greatest use cases for AI are as a sounding board to
Mm.
clarify my own thoughts.
Mm.
So you know, I'll go back and forth with the problem, trying to like define it better or to, add layers and layers until I eventually kind of get closer to the root of what it is that I'm trying to do. And then I kind of have a plan. Um, that's often how I use it.
That's really
Zooming
interesting.
out,
Yeah.
zooming in and out all the time, like like macro and micro, and just trying to kind of conceptualize. So I use it like a thinking partner, and I think
Like
that's
someone to
very
talk it out
helpful.
with, right? But now you don't need to worry about interrupting somebody's day to do that.
Exactly,
Yeah.
and I can say like the most idiotic thing conceivable, and
The
there's
things we
no
write in our
judgment.
diary.
There's no judgment. There's no like, wow, I can't believe you said that. Um,
Yes, yes, yes. Because I'm sure we've all had the experience of somebody looking at us like we're stupid. And we're like, you're like, come on, you don't need to look at me that way.
exactly. Okay, so yeah, that was a little bit of a tangent on AI stuff, which is, it's very interesting field. Um, but going back to your thoughts on engineering automation, how do you see this field developing? Like, where do you stand in this?
Well, we have, okay, so the computer has kind of become the primary tool for engineering in terms of physical tools, right? External, it's still your brain is the primary tool, but let's just say external tools. Pencil and paper is great. Calculator is great. Love them. I always like having my calculator beside me. Feel weird when I don't. And so when you're doing engineering work in a medium of pen and paper and calculator, you are going to be limited by the characteristics of that medium. So when you make a mistake, you've got to scratch it out or you start again, or you cross it out and you write it over and you get a little, make it a little bit messy. You can't sort of transfer information from one page to another page without sort of writing it out or writing a reference, say, see page, blah, blah, blah. The it takes time to write, and you are going to be doing everything manually. Now, of course, as you gain experience in engineering, you tend to need, what to write, what you don't need to write. And so you get faster in the pen and paper medium, but that's that engineering experience that will improve your speed no matter what medium, right? So the
Hmm. Hmm.
pencil and paper medium is still limiting your speed. Now, if you go into the computer and you've built this engineering toolkit, let's just say it's entirely spreadsheets, and each spreadsheet does its own thing. You got a footing calculation spreadsheet, you got a beam calculation spreadsheet, you got a steel column calculation spreadsheet. As you start working, you're now at the speed of those mediums. And the characteristics of spreadsheets, some of them are that they don't easily talk to each other. You can sort of link spreadsheets, but it's kind of like you kind of set it up and it's kind of like in stone, like it's It's a rock solid thing.
It's a house of cards.
It's a house of cards. That's yeah, because you break one reference and then you ruin the formulas. Like it'll actually delete the formulas, right? And go #ref. And you're
You're
like, damn
doomed.
it.
You're doomed. Yeah, yeah. It's a
So
nightmare.
yeah, exactly. Anyone who's ventured down there and built anything of any significant complexity knows the pain of doing that, and also the limits of doing that. It will be a more complicated version of solving one problem, right? And so the things that limit your speed with the spreadsheets are the time it takes to copy and paste the spreadsheet, the time it takes to manually enter the data in the spreadsheet, and then transferring information from one spreadsheet to another, or from one spreadsheet to another program, and the program back to the spreadsheet. A lot of manual data manipulation. You are limited by the speed of that medium. And so when it comes to so I'm going to sort of just zoom out a sec here, is that one of the things I've been thinking of lately is that the engineering happens, like the actual engineering work happens between the calculations. And I'm riffing off of a quote that I heard years ago, where it was like the music happens between the notes. And so I think very much it's that way with engineering. The engineering happens between the calculations, happens between the analyses. It's the judgment, it's the thinking, it's is this correct? Is this what I should be doing? All that sort of stuff. But then in addition to that, between the calculations is the moving the data part. And so when you're manually moving the data, no matter whether it's on paper and pencil, whether it's on spreadsheets, that is where, if that's the thing that's not automated, then that's where you're going to be spending your time. And so the process of spreadsheets now it feels less like engineering. It feels more like you're a data entry monkey,
Yes.
and it feels like you're a click and drag stooge. And you look up after 4 hours and you're like, what did I accomplish? I just jockeyed a bunch of spreadsheets for 4 hours, and you don't feel great. You don't feel like that's what engineering is supposed to feel like.
It does feel like engineering at the beginning of this process when you're trying to figure out, okay,
Yes.
like how do all these things link together, and you kind of imagineer the architecture involved of like,
Yeah.
okay, I'm gonna link this guy here, and then that's gonna do a lookup here. It's gonna pull the results from SAP or whatever. But you're right. Once you kind of get past that initial setup, then comes,
The execution.
the drudgery of like, oh my God, like, why isn't this? You're looking at those little precedence arrows to figure out where is this coming from. It's from a different worksheet. It's in a different file. You're absolutely right. It's, I have spent so much time spinning my wheels in the past on that exact issue, where it's like, I've got a good tool here, but I've just got every small tweak results in just drudgery and pain.
Yeah.
And anyway, sorry, just a side thought. Carry on.
No. I was gonna say, I call it pushing the wheelbarrow, right? Where you're like,
Yeah,
okay,
yeah,
here's what I got to do today.
yeah,
Shrudge. And
yeah,
it's just not exactly. It feels like engineering at the beginning when you are setting up the process. That's when your mind is engaged. You're thinking about it, right? But once you've got it set up and you've thought about it and you checked it and then you've validated it, then you're like, okay, now I need to do it.
yeah,
Okay, I got 2 days ahead of me of doing this.
yeah.
And
And it's
so,
the changes. It's the small.
yes,
Well, what if we move this? Oh no, don't move that, because once you move that, you have to do it all over again.
that's right. Right. And it's always going to change. Right. I think
Yeah,
engineers, we have this fantasy that it's like, yes, the job comes in across my desk. I do the job. I send it out. I'm like, damn, billable. Awesome.
yeah.
I made money.
It's
Great.
never happened. Ever.
Exactly. And then the changes are coming. God. And you act like it's a surprise every time.
Yeah, yeah, yeah.
Oh man. Anyway, so what I'm getting at is, all right. So if we take this idea is that one, the engineering kind of like happens between the calcs, and the work actually happens between the calcs, right? The moving the data around as well, right? So the thing that I've been sort of building on is this idea of, and it's very in line with what would probably be called what's called functional programming in the computer science world, is the idea of building these small reusable functions, these small reusable tools. And if we use an analogy here of building blocks, right, like a Lego block, but I'm not going to say Lego because that's trademark. So let's call it a Linko block because they link together.
Yeah, interlocking plastic blocks with
Exactly.
proprietary.
So if you've got a bunch of these small ones, right, you can make kind of any shape out of these small little blocks, right? You can just reuse and you take them apart and you could pull them back to put them back together in a different shape. And so, but if you have a bunch of blocks that are these large irregular shapes that have connection points only on certain sides, those are harder to work with because they only kind of fit in certain places. And so by analogy, I would describe these like little functions that we build as the way of building these little Lego blocks, and we can sort of pull them apart, put them back together in different ways. And we don't need to reinvent the wheel every time. We've done it. We've already written it once, so we don't need to write it again. But conversely, when you build these large spreadsheets, you're building these large like blocks that do like this one thing, and they work great as long as they fit into a process that's designed to fit for that. But if the process needs to adapt or change, then manipulating and changing that big block, you will call it, as there's a lot of pain there. It takes a lot of time, and then you've got two copies of it that you need to maintain both of them, and you're copying and pasting everything. And then, but by extension, I'm not meaning to pick on spreadsheets here because it's the exact same with if you learn Python through Python, like just like you do a quick online course, you will start off doing Python scripting, which is writing large, like I would call them one pagers of Python code that does a whole bunch of stuff. And then it's very much the same. If you execute Python code like in these sort of like single page documents, and they do all these things, it'll get this data over here, it'll pull it in, it'll process, it'll do a filter on it, and then it will transform it in some way, and then it will save it to a file, but then it will also manipulate this other data and also save it to a secondary file. And then you're like, oh, okay, I need to do that transformation part, but I don't want to do all this other stuff. Crap. It's all in this big honking one pager file that does all, it has a lot of side effects, would be a good way of putting it. And so oftentimes when Python is taught, and when especially to beginners who have limited programming experience, the teacher sort of takes this approach of like, well, I'll just show them the Python syntax and how to solve some simple problems, how to make some cool plots, how to make these fun tables. Then fun tables, yeah. Tables.
Whoa, these
Are they
tables
fun?
are a blast.
Yeah, exactly. We make these tables. But then not showing them how to approach it as though they're going to have to do this every day. And I think that one of the big differences between data scientists and structural engineers is that data scientists tend to be working on unique problems all the time. The problems are going to be different from, depending on the application, depending on who they're working for. Whereas structural engineers, we're working on the same kinds of problems all the time. And my friend Tashar, he describes it as, you're putting data into a simulation, you're running a simulation, and then you're processing the data that comes out. So like that, a high level view, that's a lot of what we do. But of course, that's really not everything that we do. And so, but it tends to be a part of it. And so, but and the other difference between structural engineers and data scientists is that we are generating our own data, right? We're running those simulations. The data that we have going in is in a certain format that we know, the data coming out in a certain format that we know. Then we need to sort of parse it and work with it and manipulate it, transform it, and aggregate it into some useful information for making a design decision. And so the nice thing about engineering is that you get to be data scientist and decision maker all in one, right? We get to make the decision, and that's what differentiates, I think, engineers from a lot of other technical fields, is that we have the authority to make decisions.
Yeah.
The privilege and the responsibility.
One on a side note, one thing that I really like, and I often work in Jupyter notebooks in a sort of a exploratory manner. Where,
same. I do too.
You're kind of building up your functions, and you have the luxury of tweaking all of your inputs, and you're seeing like, okay, well, what if I move this over here? What if I increase the depth like by this? And you can really get a great feel for be it results or structural behavior or insights into data by doing that. So I think you're right. I think we're in a kind of a unique position where we're kind of halfway in between data science and engineering. Like, at least that's for me in my role.
Yeah, one of the things we've talked about, James, is, and you touched on it earlier, right? Which is the idea that we've got in the structural engineering world, we've got people who are cranking out hollow core slab buildings. And I got to say, I saw my first hollow core building in Winnipeg a few weeks ago. I was like, oh my God, I've seen hollow core like out in the yards for the precast yards. And I know that people use it, but I've never actually seen it used in a building before. And so I saw it. I was like, oh my God, that's a hollow core building. So
Yeah, yeah.
I was really excited about that. But but yeah, there's people designing hollow core, there, components, let's call it. And then there's people that do highly varied things. And from our conversations, I know you are one of these people that does a lot of highly variable things in your day. And so I'm kind of curious to know from you is how, because I know you know Python, you've been using it for a long time. You're also in my course, PFSC Async, and I've been wanting to hear from you. Like, how are you using it right now, and what's been working for you and what's not working for you in terms of how you use Python?
I I use it in so many different ways. It kind of depends on the types of projects that I'm working on. So most recently, we carried out a due diligence for a large gas pipeline project in, I can say it's in within the Arctic Circle, and that involved a bunch of sort of technical pipeline engineering checks, but also financial analysis and sort of risk analysis of the project. So you're doing hydraulics checks, you're doing structural checks on the steel pipeline, you're doing slope stability checks on some of the pipeline alignment. Then you're trying to look at unit pricing of materials, the scheduling of how you're going to construct this pipeline when there's so many seasonal dependabilities on, like, when can we cross this huge river, when can we drill through this mountain range. So there's so many different aspects that Python is the perfect flexible tool to traverse all these different domains. So for me, like I said, I'm often in a Jupyter notebook, just sort of like, here's James at the top of the Jupyter notebook beginning the project, and you can kind of see as I move down, like, the different things that I'm exploring as I move down the notebook. And then at the end of it all, I kind of tidy it up and maybe I make it into a script, or maybe I separate it out into different notebooks. But that's generally how I use it for, at least for that particular problem. But then I also have cases where I'm, designing structural aspects of a water or power type project. Maybe it could be a spillway, it could be an intake, it could be a channel of some description, energy dissipation, that sort of stuff. So that'd be just, I'd build a Jupyter notebook, or I'd have previous modules that I've developed that kind of run me through the design. And then I'm always experimenting with, like, different libraries that might make the workflow a little bit easier, or a little bit smoother. And oftentimes the final review will be done by senior engineers who have no experience with Python. So my outputs have to be legible, clear, and presented in a way, kind of like how your Hancock's library works, where
Hmm.
people are like, okay, yeah, I can see what he's doing, I can see what the inputs are, etc. So I would say that's, in an engineering capacity, that's probably how I use Python. But I'm also building some internal infrastructure and tools for our company as well that would be more on the development side and not so much structural engineering. But they kind of both work together because the tools are for engineers, and it just means that I'm kind of on the back end doing stuff with our infrastructure.
Right, right, yeah.
I don't know if that answers your
Yeah,
question, but
yeah, it does actually. And because when it comes to building an engineering toolkit, especially, let's just assume that as an engineer, you are gaining the benefits, the profitability of your efficiency, right? Now, as an employee, that's really not the case, but that comes back to sort of in other ways where, recognition and that sort of thing. And so the more what's the word, consistent task wise or project style or project type you have, then building an engineering toolkit is going to yield higher profits, right?
Yeah.
And
Yeah.
then the more varied your work is, then the less so, right? It becomes harder to do that, because in order to kind of cover off all of those areas of practice, then you have to just build a lot more stuff. And so
Sure.
when it comes to, so what you were describing, right, is that you're doing a lot of variable stuff, and but you're working typically the same way. You're doing an exploratory work through Jupyter Notebook. So tools that might be most useful for you is ways of rapidly turning those notebooks into readable reports,
Yep.
right? And so that would be the toolkit that would sort of be like, hey, yeah, this would make a big difference to me, right? And so, whereas for hollow core engineer, they're going to be looking at doing the actual streamlining that whole design process, right? Taking inputs,
Yep.
maybe parsing drawings, reading geometry off of drawings, and then turning those into elements, and then checking those elements and running scenarios. And so, depending on every engineer's sort of practice, then you can end up with these customized toolkits. And I think that's kind of the point, is that you're going to have it be customized to you. And
Hmm.
that's something that we can never get from commercial software tools, because they are designed to be marketed, right? They're designed to appeal to the whole. And so, the more you would try to appeal to everybody, the you appeal to nobody, that old adage. It's very true, right? And anyone who's tried to develop a finite element tool, a general finite element tool, you realize, like, one, how hard it is; two, how tedious it is; three, how many features you need in order for an engineer to even consider looking at it. And then to realize that, there's far too many tools already in the market, that it's like, wow, are you going to try and compete on that, right? It becomes almost like a commodity in a sense, right? And so I think we've seen a lot of these providers make more specialized tools, right? For the
Yep.
bridge engineer, for the plant engineer, right? For retaining wall design, for the road designer, for the pipeline designer, for the offshore engineer, right?
Yeah.
And so those more specialty design tools allows you to assume more in the code, and also um, develop tools that are sort of more specialized for certain practices. But at the end of the day, I mean, unless you're dealing with steel exclusively, then it's hard to get everything into a single design software, right? And I
Of
say
course.
I
Yeah.
say steel because of, we've got a set kit of parts for a certain region, and the checking of that is sort of a lot more by the book than it is for other materials. And so it's easier to kind of create optimization processes for steel design than it is for any other material. But oftentimes, of course, your steel design, you go down to the foundation, you're like, but I'm using concrete foundation. But the steel
Yeah.
design software's got no answer for you there. You're on your own.
Yeah.
Take out
Yeah.
that spreadsheet.
Yeah. Yeah. That's yeah, it's interesting. And yeah, it's a difficult problem to solve, because I often find with using Python or programming in general, it's just about how to think. And
Mm.
if you can kind of imagine a path to the solution, it can be done programmatically.
Mm.
And that is often the hardest part. And like you say, learning the syntax and understanding how to make simple plots, and that stuff is relatively straightforward. You can pick that up in a month or two. But it's actually the thinking part, and figuring out, like you mentioned, with the unnameable trademarked interlocking plastic blocks,
Yeah.
you have to figure out, like, okay, the blue one is going to go on the bottom, and then I can put this red one on top of that, and then I can, it's like figuring out what the steps are that are most efficient for you personally and whatever your workflow is. And like you said, for me, in that specific case, yeah, generating a clean report will be very handy. And then there's other cases where I'm just doing straight up component design, where it could be beams, columns, floor slabs, whatever. Um, and in those cases, a tool, like an automated toolkit, sounds good, but it's also difficult to compete with the likes of, what is it, TEDS and SAP, which, I mean, they all cost money, but automating that with your own toolkit, I mean, I've done it. It's not as good as what TEDS can do, but it works.
Yeah. And so
And
with our own toolkits, we can, let's say we've already got these tools, right? We've got spreadsheets out there, right? We've got these analysis programs, right? They take inputs and outputs. We can, if you have a tool like Python that allows you to, I'm going to say, create blocks, then you can create blocks to interface with all of those other things, right? So any of these apps out there, there can't ever be the glue between things. What we need is
Yeah.
the glue between things,
Yeah.
and that's what Python is great for. And as you start developing these little glue blocks, you can start connecting them to your spreadsheets. You can connect them to your analysis programs, whether they take a most. I mean, not all programs have an API that you can connect to directly. Only a few do, but most of them have a text file format that you can read and write to, right? And you
Yep.
can they do exports that you can read and write to because they're in text.
Yep.
So your blocks, your toolkit becomes the sort of the glue that combines all these other processes together. And that's what makes Python unique against any app that's going to be developed in the future, or any spreadsheet that's developed. No matter how big the spreadsheet is, no matter how fancy the app is, it only ever deals with one scope. And so anything outside of that scope is untalked about. It's not even there for as far as that tool is considered. And so, but as the engineer, your scope is way bigger. And so
Yep.
in order to make all these things work, to orchestrate all this, you need those little blocks to glue everything together. And so you've got this little network of these little tools that do small things. Oh, read CSV file, write Excel file, like they're talking about basic stuff. Transform the section, filter the sections in this CSV file, right? Like we're just looking at simple um, sets of instructions, simple tasks, very small. The smaller, the better. And because when it's small, then it's repeatable. Oh, I don't need
Mhm.
to. I need to filter sections on this one, but I also need to filter sections on this table now. It doesn't matter because I've got a little tool here just for filtering sections, right? It doesn't matter what
Yep.
table they come from. I can specify what column to filter on, and it just filters. So
Yep.
the building up of these small little blocks, the smaller the scope, the more interchangeable and interconnected and reusable they become. And so when there's a lot of this is very cool. There's a lot of people building new structural engineering apps out there, right? And one of them that comes to mind right away is CalcPad, right? Fantastic tool there, and it's never something that's going to be able to replace Python, right? People are like, "Oh man, CalcPad's going to put your handcalcs library out of business," and I'm like, I don't care. Like, it's great. CalcPad's fantastic, right? I'm going to continue developing handcalcs because it's kind of solves a different problem. But CalcPad's fantastic, and it can be included as part of your overall process. So if you've developed a bunch of calc sheets in CalcPad, then you can plug into them with Python and connect the inputs and outputs into the sheet, use it as an engine to do a calculation, give you an output, and then you send that information to somewhere else. And so ultimately, the process though of building these blocks and building these interconnected sort of blocks to kind of glue everything together, it generally doesn't happen by accident, right? You can, if you start building Python scripts to do each of these things, you're building like one connection. And then that Python script, if you need to change it to do something else, then you got to like copy paste it and change it to do another connection, right? So you've almost got like the same kind of problem, but now on the glue side of things, as opposed to the node side, right? Which is like our calculations and our spreadsheets and our other applications. And so the thing that I've learned is that there is a method for developing an engineering toolkit that does this. I've written a little PDF on it recently. And if people sort of want to check that out, it's available at engtoolkit.com, toolkit.com. And I talk about that sort of high level framework, how to look at it. And especially when it comes to testing, right? You develop these blocks. How do you know they're correct? Well, you've got to test them. And how do you test them? Well, you do a hand calc. Yes, absolutely. Do a hand calc. But now instead of just leaving that hand calc out there like you did it once, you formalize it. You put it into a test block, right? And then that test block has got your, these inputs should give these outputs, and you've documented the behavior of your block. You should just be able to print that file out, and there's your documentation of your validation. And so you've got these you've got this methodology now for a framework that's possible for building out an engineering toolkit that has this reusability, this compoundability. You build one block, you don't need to build it again because you built it small enough that now it does that one job really well and you've checked it. And you now, whenever time you need that, you just plug the block in. You don't have to rewrite that functionality. You don't have to copy paste. You don't have to sort of be building up this like pile of maintenance in folders that you need to worry about, right? You're building up tools that are checked, they're automated, and you can connect them together in that thinking process, right? You're talking about at the beginning of the spreadsheet. That's where the creative part of engineering comes in, right? You
Yeah.
connect them together once, and then you put them in a for loop, and you hit
Yes.
go, and that's it.
You've the challenge with this is you're talking about this broadly because you have to, because you're explaining the concept. But every engineer out there has their own specific workflow, their own specific
Yeah.
problem that they're trying to fix. And I spoke internally here with one of the girls that I work with who was trying to kind of do something similar with, I think it was like gauge monitoring stations for water levels that were on drawings. She was trying to pull them off the drawings, then use them for some other process. And I worked through that with her, and it was it was exactly as you described, where you have to understand you're starting at point A, and you have to understand every single small step and crossroads along this journey of where you're going to get to point
Journey.
B.
Yes.
And you can talk about it broadly, but if you want to execute what you have just described, which is like to automate a part of your workflow, you really need to understand the entire pipeline of like what is the infrastructure of A to B, like every small tedious step. And the more robust of a definition that you can apply to that A to B journey, the better your solution is going to be. And what happens is you have like maybe a manager, an unnamed manager that just says, "Hey, Connor, let's get this from A to B. We've got like 1 week," and then you then have to figure it out. And I think that's the heavy lifting
It is the heavy lifting.
is figuring out like every single tedious little step here. You can't miss anything or it's not going to work.
That's right. And if one of them's wrong, then they're all wrong.
Yeah.
Yeah, absolutely. And I think that's one of the first point on the PDF document I wrote is that you got to know your scope. You have to know it intimately. If you wanted to create an automation, you've got to be able to list out all the steps on paper, right?
Yeah.
And this is great. And I think it was on you interviewed Craig Brink who develops Pynite, right? And on the interview that we did on the structural engineering podcast a little while ago, he was talking about when you program, you have to. It's like you're teaching the dumbest possible student how to do something, right? It's like your computer doesn't know anything, so you got to tell it everything, right?
Yeah.
And that process of explaining it, you get to become very clear on what it is that you're doing. And I've had that exact experience where at RJC, I was involved with developing a tool for designing concrete buildings. And in that process, I hit on several spots where I was like, hey, what do, come back to code interpretation as well. I was like, what do people do in this scenario? I go ask like 4 engineers. They're all like, take the average. Wait, take the max. The max of what? The max of, the max, when you're talking about a series of data, the max is like the max per floor or the max of all floors, and then like,
Yeah.
so it becomes very, you find ambiguity in the engineering process, and you have to make a call, whether you're the person to make the call, or if you've got someone senior on the project who's going to make that call for you, but you got to sort of get clarity, right? Yeah. And that process of defining what exactly you're going to do and what exactly the steps are, that's also like really the engineering work. What are you going to do?
Yeah, it's tough. And you run into those little roadblocks, and then it's like, take the max. And they're like, okay, well, it looks like all of these columns are absolutely gigantic. The building no longer makes sense.
This doesn't make sense. Yeah. That's right. You got to go to the testing and validation, right? And it's so easy also, if I find it as an engineer, especially when you're sort of younger and you're put into the detailed design work, you start getting this myopic, like, okay, well, this number makes sense. That might make sense. That goes here, right? But it's like, well, the big picture is like, well, but does what we're even doing make sense?
Yeah.
Right. It can be
Yeah.
hard to sort of step out. Right. And so I think that's also part of the tool, or part of the process rather, for building these tools, is that you always have to be able to have the high level view, and you have to be able to zoom in and break
Yes.
everything out into little pieces, right? Break all the steps out individual into subtasks, sub problems, right? And as
Yeah.
engineers, I think we're generally pretty good at that. And then, but when you do it in a computer, then you realize that it's how strict that discipline has to be.
As a general comment, w- before I started using Python more, like I, I thought I had a good understanding of processes and systems, but it has improved dramatically since I started programming more, because you're forced to think with just a ruthless logic where it's like, well, it's not going to work unless you can figure it all out from A to B. And it has been massively helpful just in terms of engineering problem solving in general. Like, I kind of tend to find myself thinking more programmatically about general engineering problems. It's just a weird symptom of doing a lot of programming, I think.
Yeah, a side effect, right?
Yeah.
It changes how you think, and I think that there's in the software development world, people who get to become very good at it, they also get a sort of a delusion of like, hey, I can apply this thinking to all problems, and you're
Yeah.
like, yeah, except there's also people
Yeah.
and emotions, and so
Yes.
there's
Yeah.
limits there. But in terms of our work, and well, actually, that's not true. Even in our work, especially I think in your field, because you're working in public infrastructure, right? There's also people and emotions and all sorts of stuff that comes with it beyond the technical solution, right?
Sure.
And so,
Yeah.
but that being said, though, in order to get to that technical solution, that breaking the problem down, absolutely, right? And I find that the exact same is that I can think a lot clearer. And the other part of that is when you're writing code, you're writing, right? And so the process of writing even is just a great way to clarify your thinking. And I find
Yeah. I do it
oftentimes,
all the time.
yeah, writing, absolutely writing, because you're talking about writing, into prompts into the the LLM to have as a sounding board, right? You're writing, and having somebody asking you some questions back that you maybe wouldn't have been thinking of. And so I say someone
Yeah.
having an LLM send questions back to you that you maybe haven't thought of. Yeah.
Yeah. Yeah. It's true. Um, okay, Connor, we're running low on time. Let's give the listeners sort of like some parting information as to what your plans are with this engineering automation concept, where they can go for more information, and yeah, let's leave it there. What have you got to
Sure.
say on your plans?
I'm working on a new course. I've been working on Python for structural engineers, was built on the SEABC model, which itself is modeled on a graduate level university course. And I have been, after doing PFSE live and then developing PFSE async, I basically have been refining the course in that format. And belatedly, it occurred to me that maybe that university level graduate course is not the best format for practicing engineers. And so I have been working behind the scenes to develop a new format of a course that also really focuses in on this idea of building an engineering toolkit. And the whole idea of this new course is that it will teach you the Python you need to know to automate the part of your job that bothers you the most. And it teaches you sort of the minimum and gets you done fast. And so that is really, I think, speed and time. We don't have much of it. I think that, I'm feeling like, man, I developed a course that took 12, 13 weeks. My God, it's a very comprehensive course, and it fills in a lot of information. But I think what I found is that the majority of the people in the course are able, what they need to know is sort of is not that scale. And so what they do need to know is how to sort of develop that first automation and how to develop it intelligently, how to develop it with this framework in
Yeah.
that way that allows them to do their first automation, get that success. And that same framework allows them to build their second, their third, their fourth, and every one they build becomes easier and easier because they're reusing the same components that they started using from their first. And so that's what I'm sort of, that's where I'm going. That's what this new course is going to be about. I don't know exactly when it's going to launch or any of the real details yet. It's still in process, but that will be in November.
Cool. Very cool. And in terms of automation libraries, I use Selenium a lot.
Oh,
I
really?
don't know, are there any specific other tools that you like to use
Right.
for that type of work?
Right. For listeners, Selenium is a tool for automating your web browser and for automating, clicks and reloads and all the stuff that a web browser can do. Um, I've played with so many. I was playing with Papermill for a while, which automates the generation and parameterization of notebooks. But they became really unwieldy, I found, especially because we're doing the same things all the time, right? And so if I'm running a report once a month, is different than when I'm rerunning calculations dozens of times a day. I've tried that. I've played recently with a little bit with Pi Auto GUI, which automates your operating system. It like moves your mouse and clicks for you and like
So
types.
Selenium does that as well. Selenium has the WebDriver, but it
Mhm.
also has an OS based
Oh, does it?
automation
I didn't know that.
part that you can do the exact same thing. Drive your mouse around and
In your operating
operate
system
your
out of the browser.
yeah, yeah,
Oh, cool. No, I didn't know that. Thanks for telling me.
yeah. No sweat. It's good. It's good. I use it for most of my automation.
Ah, beautiful, beautiful. Yeah, so I'd love to try out Selenium a bit more because yeah, I haven't used that. There's also another one that does that sort of abstracts it, I think, a little bit called Playwright. That one I think
Oh,
is
I've heard of that one.
yeah,
Yeah,
that one's in the
I haven't
browser
used it.
and but it allows you to do sort of write less code to do the same amount of stuff, which is really nice. Um, and in terms of other automation stuff, I mean, ultimately the automation is really running the for loop, right? You set up the process and then all the steps in the process, then you run the for loop and you iterate over it, right? And you get it all done. And so ultimately it's Python that I'm using for that automation part. But I was just going to say, ultimately, it's just what I use the automation for is just Python, right? You set up the process, and then you stick that process into a for loop. You do the iteration, and that's it. And so I've done that in one of the area that I did that most in was in wood frame design.
Very nice. Okay, cool. Like let's have another chat soon because I feel like we could go into a lot of different topics and we only kind of scratched the surface of a lot of stuff today, but it was just really interesting to get another engineer's perspective on how to approach automation. This is something that I think about a lot, and I feel like a lot of people are thinking about this these days. Like we all
Mm-hmm.
have, there's such a wealth of high quality free tools available to help you do your job, and you just need to understand how they work, and
Yeah,
the floodgates open,
yeah,
and it's extraordinary what you can do. And I feel too that there's more and more interest from uh, engineering graduates. People are coming out of school now understanding the value of programming skills. However, it's not really that common because a lot of engineering curriculums are just already so densely packed with engineering material that they don't have the space for adding programming and Python in there. But I think it's starting to change a little bit. Do you have any insight on that?
I was bringing it up with the applied science department at UBC, and because they are still teaching the intro programming course in year one as in C++, which the only people in that first year course that's going to be useful for is the electronics engineers who end up developing embedded systems. For the rest of us, it's entirely useless because it's not the language to write small tools in to generate a plot for your report in. It's the tool for building applications and compiled libraries for distribution. It's one of those languages, I should say. And so, but the feedback and the pushback I got was like, oh, well, Python's a dynamic language, therefore it doesn't fit the curriculum. And I'm like, oh, come on. The way I was taught was at the University of British Columbia in a computer science course, but it was a computer science course for non-computer science students. And they developed a course along the same curriculum, which was teaching static typing. And they just treated Python as a statically typed language. And they did type checking, which has become available in Python, I think in Python 3.5, was it, where we had type annotations added in? It was a while ago now. And so type annotations have become, I think, the way to write contemporary Python code now. So, I mean, to fall back and like to hide behind the static typing is kind of like,
yeah, it's a ridiculous argument.
It is a ridiculous argument, and it's just kind of really short-sighted. But yeah, it can be taught. And my feeling about university education, engineering education, is that we could teach it in a way that every course and every year builds on each other. And that's, we have a little bit of that, right? You got like water resources 1, water resources 2. If you teach them Python in that first year and how to generate plots, how to clean up data, wow, they're going to use that 4 years and beyond.
Yep. Yeah, for everything, for everything, for every discipline, every domain. That's like practical for everything.
Yeah. I mean, the way I've said before is that like we don't get taught how to deal with data, right? In our education, anywhere.
I touched on it a little bit, and it's such a huge part of the role, and it's only going to increase, as time goes by, and we're all buried in data. Every professional is buried in data.
Mm-hmm.
This is a conversation for another day. Connor, thank you very much. Always a pleasure to chat, and let's meet up for a dinner or a drink sometime soon. And let's get all of your information in the show notes. Everybody, whatever you need related to Connor Ferster and his shenanigans will be in the show notes. Also, you can check out your excellent Python libraries, For All People and Hand Calcs. Is one of those a units based? That's For All People,
yeah,
right?
For All People is the units. It's the SI units, or For All People for all time. And so I've got, and one of the things I'm so excited about is that now that I'm working on structural Python full time, I'm over the next year I'm going to be able to do a lot of open source, and I'm so pumped to really kick it up a notch in my open source contributions.
Speaking of which, I know you made some modifications to Pynite recently, and I opened up an old work file that I was working on.
Yes, we've done breaking changes.
I was like, what is the problem here? And then I realized that some of the methods were using like camel case, and you had adjusted them all to lowercase. So,
yeah, and then Craig merged that PR, which was awesome. We've been working as him and another engineer and I have been working on a sort of doing some changes here to get Pynite ready as a version 1.0 release, meaning that the names of the commands won't change in the future, which means that all your old scripts will continue working in that version 1 range.
Yeah, I love Pynite, a big fan.
Me too.
Anyway, Connor, thanks for everything that you're doing to push Python in the industry. We're a huge fan of that in this podcast, and look forward to chatting again.
Man, pleasure, James. I always love listening to your podcast, man. You've got such a relaxing voice. Oh, love it.
Thanks.
All right, man. Take care.
See ya.